Imagine a future where humanity taps into the full power of the sun. Enough energy to fuel every device, vehicle, and city on Earth indefinitely. It sounds like the realm of science fiction. But this concept, known as the Dyson Sphere, could one day revolutionize our civilization. The big idea. Let's start with a staggering fact. The sun emits approximately 3.8 times 10 to the 26 power watts of energy every second. To put that into perspective, this is equivalent to the energy output of about 100 billion 1 megaton nuclear bombs per second. Currently, Earth intercepts only a minuscule fraction of this energy, about 1 part in 2 billion. Our existing technologies like solar panels and wind turbines capture an even smaller portion, akin to scooping a cup of water from a vast ocean. In 1960, physicist Freeman Dyson proposed a thought experiment. As a civilization advances, its energy demands will inevitably surpass the resources available on its home planet. To sustain such growth, Dyson envisioned constructing a colossal structure around a star to capture its energy output, a concept that has since ignited the imaginations of scientists and science fiction writers alike. But how could we possibly build such an immense structure, and what would it look like? Let's explore these questions. What is a Dyson Sphere? The term Dyson Sphere encompasses various theoretical designs, all aiming to harness a star's energy. Contrary to popular belief, Dyson didn't propose a solid shell encapsulating the star. Instead, he imagined a swarm of satellites orbiting the star, each collecting solar energy and transmitting it back to the home planet. This concept is known as a Dyson swarm. The idea traces its roots to science fiction. In his 1937 novel Star Maker, Olaf Stapledon described advanced civilizations restructuring their star systems to optimize energy collection. Dyson's 1960 paper, Search for Artificial Stellar Sources of Infrared Radiation, formalized this idea, suggesting that such megastructures would be a natural progression for energy-hungry civilizations. Now that we understand the concept, let's delve into the possible designs and the challenges they present. How could we build a Dyson Sphere? Designing a Dyson Sphere presents monumental engineering challenges. The two primary concepts are the solid shell and the Dyson swarm. Solid shell. A solid shell completely enclosing the sun is often depicted in science fiction. However, this design faces insurmountable obstacles. The structural integrity required to withstand gravitational forces and the immense pressure from the star's radiation makes it unfeasible with any known materials. Additionally, the sheer amount of matter needed would likely exceed the combined mass of all planets in our solar system. Dyson swarm. A more feasible approach is the Dyson swarm, a vast assembly of solar-collecting satellites orbiting the star. Each satellite, or solar collector, would capture solar energy and transmit it back to Earth or other habitats. This design allows for incremental construction where satellites can be added over time, gradually increasing the system's energy output. To construct a Dyson swarm, we would need advancements in several key areas. Materials science. Developing lightweight, durable materials capable of withstanding the harsh conditions of space. Robotics and automation. utilizing self-replicating robots to mine asteroids for raw materials and assemble the satellites. Energy transmission. Establishing efficient methods to wirelessly transmit the harvested energy over vast distances, potentially using microwave or laser-based systems. Building such a megastructure is a daunting task, but why should we consider undertaking it? The answer lies in our future survival and advancement. Why bother? Our current civilization is classified as a Type 1 civilization on the Kardashev scale, meaning we harness energy from our planet's resources. However, these resources are finite, and as our population and technological capabilities grow, so does our energy consumption. Transitioning to a Type 2 civilization involves harnessing the energy output of an entire star, providing access to energy levels far beyond our current means. This leap would not only secure our energy future, but also enable endeavors such as interstellar travel, large-scale terraforming, and the construction of habitats capable of supporting billions. Moreover, relying solely on Earth's resources makes humanity vulnerable to planetary-scale disasters, both natural and self-inflicted. Diversifying our energy sources and expanding our presence beyond Earth could serve as a safeguard against such existential threats. If the benefits are so compelling, could it be that other civilizations have already built Dyson Spheres? And if so, how would we detect them? Are Dyson Spheres already out there? The search for extraterrestrial intelligence, SETI, has expanded beyond listening for radio signals. One intriguing approach involves searching for the waste heat that a Dyson Sphere would emit. Since these megastructures would capture a star's light and re-emit energy as infrared radiation, astronomers can scan the cosmos for stars exhibiting unusual infrared signatures. In 2015, the star KIC 8462852, also known as Tabby Star, exhibited irregular dimming patterns, leading some to speculate about the presence of an alien megastructure. While subsequent studies attributed the anomalies to natural phenomena, such as dust clouds, the incident highlighted the potential of this detection method. Ongoing surveys continue to search for such signatures. For instance, a 2024 campaign identified 7 possible Dyson Sphere candidates, though further investigation is required to confirm these findings. Detecting a Dyson Sphere would be groundbreaking, but the question remains, could humanity ever construct one? Let's assess the feasibility. Could we build a Dyson Sphere? Building a Dyson Sphere would require an unprecedented global effort, not just in engineering but also in logistics, resource allocation, and long-term planning. While we currently lack the necessary technology, developments in AI, material science, and space mining could one day make it a reality. While the obstacles are formidable, humanity has a history of turning the impossible into reality. Could the Dyson Sphere be our next giant leap? The future is bright. The Dyson Sphere remains a theoretical construct, but it symbolizes humanity's boundless curiosity and ambition.